Hello everyone, this is Sedi and welcome to Sedi's Mathverse. For today's video, we will discuss significant figures, which is tutorial number 11. Without further ado, let's get started. To begin with, significant figures are digits of a given number which add to the overall meaning or value of the number. So basically, significant figures are the ones which gives significance to the given value, hence the name significant figures. But how do we determine which figures are significant and which are not? We have 5 rules in which we can use to determine how many significant figures does a number have. So let's discuss each rule one by one. Rule number 1, all non-zero numbers are significant. For instance, 579 has 1, 2, 3 significant figures. 6.212 has 1, 2, 3, 4 significant figures. 63.11116 has 1, 2, 3, 4, 5, 6, 7 significant figures. Rule number 2, zeros between two non-zero digits are significant. So, for example, we have 508. This zero is between the two digits that are non-zero. So this is a significant figure as well, which means that this has 3 significant figures. The same goes for 6002, wherein we have 1, 2, 3, 4, 4 significant figures. Then 5.103 also has 4 significant figures. Rule number 3, leading zeros are not significant. For example, 0.00047. These are leading zeros. There are no non-zero number besides this zero, and these 4 zeros are appended by these 47, which means that these 4 zeros are not significant. And the only ones that we will count are 4 and 7 for a total of 2 significant figures. Using the same logic, we have 0.00552 with 3 significant figures and 0.00001 with 1 significant figure. Trailing zeros to the right of the decimal are significant. For instance, 6.00. Remember that these are trailing zeros to the right of the decimal. As we can see, there is a non-zero number here. So we have 1, 2, 3 significant figures. 62.000 has 1, 2, 3, 4, 5 significant figures. Then 60.00 has 1, 2, 3, 4 significant figures. Since these are significant, this will also be significant. Trailing zeros in a whole number with the decimal shown are significant. For example, 4,200.00, as we can see, the decimal is shown. And remember from rule number 4, these are significant. So these two are significant as well. So we have a total of 6 significant figures. Using the same logic, 5050.000 has 1, 2, 3, 4, 5, 6, 7 significant figures. Then 10,000.000 has 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Now, we proceed with rounding of numbers depending on the number of significant figures given. For instance, we need to round up this to 3 significant figures. Okay? This is a significant figure. And this 0 is also significant because it is between two non-zero numbers. This is 55. I'm sorry, my bad. Then this 2 is also significant. So we now have our 3 significant figures that we desired. And now, we will round 2 up or down depending on the next digit. 6. 6 is greater than 5, greater than or equal to 5. So we round up the number. So we have 4.03. Alright, another problem. Round up 0.00124 to 2 significant figures. So we have these 3 being non-significant. So we begin counting from here. 1, 2. And we now have the 2 significant figures that we need. 0.001. Okay, since 4 is less than 5, we will retain the value of 2. So rounding off, this gives us 0.0012 as our answer. Now, here is an example problem that seems a little more interesting than the other two. So the problem is round off 60.001 to 2 significant figures. So we count as usual. 1, 2, these are 2 significant figures. But when we rounded this off, we get 60. 0 is less than 4, which is the third digit. So we round down or retain. However, 60 has only 1 significant figure, but we need 2. Can we think of an approach? Maybe we can add this digit. So we will round using this digit instead. 60.0 rounding off, we have 0 less than 4, so it is retained. 60.0. But this isn't the correct answer. It has 3 significant figures, 1, 2, and 3. How do we express this 60 into 2 significant figures? We will use scientific notation. To finish this problem, we can express 60 as 6.0 times 10 raised to the first power, which means that we can now have 2 significant figures because of rule number 4. 6.0 times 10 raised to the first power. And this is our answer for a rounding up problem. Now, we will discuss the operations on significant figures. For addition and subtraction, we have 2 steps. Step 1, add or subtract the 2 numbers or any given number of numbers normally. Step 2, round the numbers off to the lowest significant figure after the decimal places among the original given. Alright, so let's have some examples. 36.16 plus 5.224. We will do step 1, which is adding the numbers as it is. So we have 41.384. Now, we will check the number of significant figures after the decimal places. 16 has 2, then 224 has 3. Now, we need the lowest significant figure, so we have 2. Lowest number of significant figure is 2, so we will round up 1, 2 significant figures after the decimal places. So, this 4 is less than 5, which means that we will retain our answer, 41.38. Now, let us try subtracting. 66.2 minus 7.899. Okay? Step 1, subtract as it is. So we have 58.301. Then, remember, this is one significant figure and this is 3. So, we are rounding to one significant figure after the decimal place. So, 0 is our digit here and 0 is less than 5. So, this 58.3 will be retained. 58.3 is our correct answer. Now, for our last operations, multiplication and division, we have the same 2 steps. However, there are some differences. Step 1, multiply or divide the 2 numbers normally. Step 2, round the numbers up to the lowest number of significant figures among the original given. As we can see, in addition and subtraction, the decimal places are the only ones that are considered. But here, we consider the whole number itself. Let's give it a try. 36.2 times 3.7. We multiply it as it is, and we get an answer of 133.94. We will count the number of significant figures for each number. 1, 2, 3, and 1, 2. So we will round it up to the nearest 2 significant figures. 1, 2. Since 3 is less than 5, this 1, 3 will remain and will not change, and the answer is 130. How about division? 44.62 divided by 3.8. Okay, this has 4 significant figures and this has 2 significant figures. And dividing this gives us 11.7421 and so on. But all we have to do is to round up this number to the nearest 2 significant figures. 1, 2. Since 7 is greater than or equal to 5, we will round up 11. So the answer for 44.62 divided by 3.8 equals 12. That is it for today's video, ka-Mathverse. I hope you learned something and enjoyed this video. If you did, subscribe to our official YouTube channel and follow our social media accounts whose links are shown here. That is it, guys. And remember that mathematics is incomplete without you, and chase your greatest moonbeams. Till next time. Before I end this video, I would like to give shoutouts to the following people: Benedict Feliciano, Christian James Buenvenida, Raymart Florano, and Stephanie Cal. Thank you everyone for supporting the channel and see you next time.